Okay, so imagine this. What if an AI could run its own research? And I don't just mean analyzing data. I mean actively experimenting, changing its own code, and making itself better, all while you're sleeping. Well, that's the wild and fascinating idea behind Andrei Karpathy's project, Auto-Research. Let's get into it. Right from the start, the project kicks off with this incredible quote. And get this, it's dated from the future, March 2026. It paints this vivid picture where human researchers, aka meat computers, are basically a thing of the past. It sets the stage perfectly. This isn't just code, this is the origin story of a revolution. So that makes the question, right? Is this just some cool science fiction? Or are we actually looking at the very first step toward a totally new way of doing science? Well, this project argues it's the beginning of a new reality. So let's really dig into that ambitious idea. Now, the core concept here isn't about completely replacing humans. It's more about creating a powerful new kind of partnership, one where the AI handles all the tedious, repetitive, experimental grunt work. Here's the what if that started it all. What if you could just set up a machine learning environment, give an AI agent the keys to the code, and just let it run hundreds of experiments on its own? You could literally wake up in the morning and not just have a pile of data, but a better, smarter model that the AI built all by itself. So what is this thing really? How does this huge idea get boiled down into a practical tool? Because that's what it is. This isn't just a white paper. It's a real repository you can go download and run this very second. At its core, auto-research is just a beautifully simple, self-contained system. You've got an AI agent, and you give it one single job. Make this model better by editing the code. That's it. It's a simple premise, but the implications are just massive. And what's so cool is how simple the project structure is. Seriously, it all comes down to just 3 files. You've got prepare.py, which just sets things up. Then there's train.py, that's the agent's playground, the only code it's allowed to change. And finally, program.md, which is where you, the human, come in. And this brings us to a really crucial point, the division of labor here. This isn't about letting an AI just run wild. It's a very carefully designed collaboration, a partnership between the human researcher and the AI agent. This chart just lays it out perfectly. The human is the strategist, the architect. You edit that program.md file to set the high-level research goals. As Karpathy puts it, you program the program. Then the AI agent becomes your tireless lab assistant. It's the one in the trenches, modifying train.py and running experiment after experiment to make your strategy a reality. So how does the agent actually do its work? Well, it follows this simple but incredibly powerful loop. First, it makes a little tweak to the code. Then, it runs a super quick training session. After that, it checks if the results got better based on a specific metric. If they did, great, it keeps the change. If not, it throws it away and goes back to the old version. And then it just does that over and over and over again, constantly trying to find a better solution. Now, this whole process is so effective because of a few really clever constraints. Think of them as the rules of the game, rules that keep the research focused, efficient, and surprisingly powerful. Okay, rule number 1, the agent's world is intentionally small. It can only touch one single file, train.py. This is brilliant because it keeps everything manageable. Every single change is isolated, which makes it super easy for a human to look at the code and understand exactly what the AI figured out. And the second rule, honestly, this might be the most ingenious part of the whole setup. Every single experiment, no matter what the agent changes, runs for a fixed wall clock time of exactly 5 minutes. So why does that 5-minute rule matter so much? Well, 2 huge reasons. First, it makes every experiment an apples-to-apples comparison. A giant model that trains slowly is judged on the exact same footing as a tiny one that trains fast. And second, and this is the real kicker, it forces the agent to find the absolute best model for your specific hardware. It naturally discovers the most optimal model you can possibly train in 5 minutes flat. It's pretty clear this simple, powerful idea has really struck a chord with people. So let's just take a step back and look at the impact this is having and what it tells us about the future of research. I mean, just look at this number. The project has absolutely exploded in popularity, with over 30,000 stars on GitHub. That's not just a niche tool for a few academics. That's a sign that thousands of developers are looking at this and seeing its massive potential.
And it goes way beyond just stars and likes. The community is actively taking this idea and running with it. We're already seeing all these different versions or forks pop up that adapt auto research to run on all kinds of platforms like macOS and Windows. It's making this new way of doing science accessible to way more people.
So, the real takeaway here is that auto research is so much more than just a clever piece of code. It's a template. It's a new paradigm for a future where a human researcher's job is to ask the big questions and then guide these swarms of AI agents as they do the tireless work of discovery. And that leaves us with this huge, fascinating question. We've started with something we understand pretty well, optimizing a machine learning model. But once this paradigm really catches on, what's next? What other incredibly complex systems, from drug discovery to climate modeling to material science, will we hand over to these autonomous AI researchers? It really feels like the story is just getting